We are going to be working on the second set of notes, and today we're just going to focus on the front page of these notes. We will save the rest of the notes for class tomorrow. So, notice we're back to graphing, and we are going to be graphing by hand instead of using a calculator because it will help you understand the domain and range a little bit better. So notice I have an X, Y, T chart on my board. So somewhere on your paper you need to get a T chart. Just make sure you're going to have to answer, you're going to have to fill in something for domain and range, but other than that you should be able to get room for your T chart next to the graph. So typically when we did T charts we would do -2, -1, 0, 1, 2. The reason we don't want to do that this time is, first of all, I can't take the square root of a negative. If I take the square root of a negative, I get an imaginary number, and these graphs represent real number. It's a real number system, so I can't put imaginary numbers on there. So I definitely can't take any negatives. And for example, like if I picked 3, I can't take the square root of 3. I could take the square root of 3 on a calculator, but I would get a decimal, and then plotting decimals becomes a little bit difficult. So when we pick our x values for our t-chart, we want to kind of pick them strategically so that all the numbers work out nicely. So the smallest number that I can take the square root of is 0. So we're going to pick a 0. The next value that I can take the square root of is 1. I can take the square root of 4. And I can take the square root of 9. Obviously I could keep going, but we're not going to graph. We don't want to plot that many points. So if I plug 0 into the function, so my function is the square root of x. So if I plug 0 in for x, the square root of 0 is 0. If I plug 1 in, the square root of 1 is 1. If I plug in 4, the square root of 4 is 2. And if I plug in 9, the square root of 9 is 3. So now that we have these values, we're going to create our picture by plotting the points. So I have a 0, 0. And we have a 1, 1. And then we have a 4, 2. And I don't have room to get to 9, but you should have enough room on your paper. 4, 5, 6, 7, 8, 9. So it'd be somewhere over there. And when I look at these dots, you want to figure out how to connect them. So when I look at my x values, the next value I could put in would be 16 and then 25. So notice that my x values are growing to the right. So we are going to draw our graph going to the right. Notice it's not a double-headed arrow because I can't put -1 into my chart or -2, so at 0, 0, that's it. It's only growing. It stops at 0, 0. It can't grow any farther. So this function is what we call a function that has a domain restriction. So up until this point, every picture we have done has had a domain of all real numbers, or -infinity to infinity. Now when you look at this chart, it's not growing in both directions. It's only growing to the right. So my domain is all my x values that are greater than or equal to 0. So this is something that is completely new. All of our domains have been -infinity to infinity at this point. My range, my y values, so if I'm looking at my y values, the smallest y value I have is 0. So it's y is greater than or equal to 0. So, different domain. We've had ranges like this before. And this is the parent function, or this is what the standard square root function looks like. So the next one we're going to talk about is the cube root. And again, just like we picked 0, 1, 4, 9, because those are perfect squares, we want to pick perfect cubes. So I can take a cube root of -8. I can take the cube root of -1, of 0, 1, and 8. And the next two numbers I could put in my chart would be a -27 and a +27, so it's going to keep growing. So if I plugged in my x value into the equation, so the cube root of -8 is -2, because -2 times -2 times -2 is -8. Cube root of -1 is -1, and the cube root of 0 is 0, and the cube root of 1, a +1 is 1, and the cube root of +8 is 2. So we're going to get these values on our graph. So we're going to plot these points. So I have a 0, 0, a 1, 1, -1, -1, and an 8, 2. So 1, 2, 3, 4, 5, 6. I don't have room. It's going to be somewhere all the way over here. 2, 3, 5, 6, 7, 8. I'll just plot my point over here on my t-chart. And we're going to connect our dots. And this time, it's going to be a double-headed arrow because my graph could grow in both directions. I could put a positive 27 in and then take the cube root of 27. I could put a negative 27 in and take the cube root of that. So notice it's growing in both directions. So that means our domain is negative infinity less than x less than infinity, or you could say all real numbers, whichever symbol that you use. So one of the difference between cube root and square root is that cube root, any x value can be put into the cube root. Similarly, my range would be negative infinity less than y less than infinity, or all real numbers. I would accept either, because my y values are also going to keep growing in either direction. So this is the parent function, or the standard one for the cube root. So the last example for today is going to be going back to a square root, but I want you to notice that this time there is this x plus 3 underneath the square root. So the goal is we need to set x plus 3 equal to all my perfect squares. So I'm going to set x plus 3 equal to 0, and I want to set it equal to 1, to 4, and to 9. Because 0, 1, 4, and 9 are my perfect squares. So if I set x plus 3 equal to 0 and I solved that, I would have to subtract 3 from both sides. So x would equal negative 3. So we're going to use a negative 3 as my first value in my t-chart. Then I'm going to set x plus 3 equal to 1. And when I subtract 3 to solve for that, 1 minus 3 is negative 2. I'll set x plus 3 equal to 4 now. Again, subtracting the 3. 4 minus 3 is 1. And then x plus 3 equal to 9. 9 minus 3 would be 6. The reason we have to kind of make this modified values is, for example, if I use just a regular 0, if I plug 0 into my square root, 0 plus 3 is 3, and now I try to take the square root of 3, and that does not work out nicely. So we want to pick these numbers to force it to work out nice. So if I plug negative 3 in for x, so everywhere I see x, if I plug in a negative 3 plus 3 is 0, the square root of 0 is 0, 0 minus 5 is negative 5. Next we're going to plug in negative 2. Negative 2 plus 3 is 1, the square root of 1 is 1, 1 minus 5 is negative 4. Then we're going to plug in 1. So 1 plus 3 is 4. The square root of 4 is 2. 2 minus 5 is negative 3. And lastly, we're going to plug in a 6. 6 plus 3 is 9. The square root of 9 is 3. 3 minus 5 is negative 2. So now we plot these points. So I have a negative 3, negative 5, a negative 2, 4, a 1, negative 3, and a 6, negative 2. Okay, and again it's going to be growing to the right because my values, my x values, are going to get larger. So this time the domain and range are going to be a little bit different. This time my x values are greater than or equal to negative 3, not 0 this time, and my y values are greater than or equal to negative 5. So that's all for today. We're going to pick up with the rest of the notes tomorrow.